America with the fam. My uncle, my aunt, my cousins, my other auntie, my brother. At home now, chilling like a villain.
Man, ain't no one chill. I'm trying to sleep, man. You can just Snapchat.
This brother is very...
There's a clip from Seattle I just wanted to show you so that you can get a glimpse of my life. Anyways, I miss you all. Let's get on with the lesson for today. Okay, today we're going to learn something called mean, absolute, deviation. I'm going to go through each and every one of those words, but we say let's get mad. M-A-D. Mad. Okay? Mean, absolute, deviation. Before I do that, let me tell you another Korean word. I forgot to do that today. Today's word is the word yes. And that, in Korean, is ne. Not teach me how to ne, but just ne. I'm just kidding. Okay, so if I say, are you fine today? Ne means yes, I am. Yes. Ne. Simple, right? Alright. Ne. Okay, back to today's lesson. Let's go through each word. Mean is average. We know that. Absolute means distance, okay? So if I'm talking about distance, this number is always going to be positive because distance can never be negative. Can you walk -5 miles? No. Distance is always positive. Deviation is a hard word. Deviation is pretty much going away from the path. Going away from the path. Going away from the path. So, let me give you an example of what deviation means. For example, say this is your car. You're supposed to be going on the path, but to deviate from the path means you're going off the road, off the path. You're doing something that is not planned. So, like if I say, please do not deviate from the plan, it means please do not go off the plan. Does that make sense? Alright, anyway, those are the 3 vocabulary words. Mean, we know. Absolute means distance, always positive, and deviation, going away from the path. Now, we will get into math. So, the mean absolute deviation means the average of how much the data values differ from the mean. Okay, that's a handful. Let's think about what this means. Give an example. I will give an example which will make this a little bit more sense, okay? Okay, so I want to find the mean absolute deviation of the set of datas. Okay? The first step is to find the mean. So you find the mean, and what you do is you add all those numbers up together, and I did that already. It's 24, and then you divide it by how many numbers there are. There are 8 numbers. So my mean is 3 in this example. That's the first step.
Of the data.
So we found the mean, that's the M part of mad. Then we're going to find the absolute value. Basically, we're going to find the distance of each value from that mean. Okay, so we take each value, 1 minus 3, which equals -2, but we're only going to take the positive side because we're talking about distance. So forget about negative, you're just going to subtract, okay? So we did that one, we're going to take the next one, 2 minus 3, which is -1, but we're only taking the positives. And then we have 2 more of those, so 2 minus 3, which equals 1, 2 minus 3, which equals 1. We're only taking the positive side. Then we do 4 minus 3, 1. Then another 4 minus 3, 1. Then another 4 minus 3, 1. Then a 5 minus 3, which is 2. So we're taking each value, each data set, and we're subtracting it by the mean. Okay? So we have all these numbers right here. Alright, so I just rewrote it all. Okay, this is my absolute value of my of the mean subtracted by the value. Then my third step will be you're going to find the mean of these answers you found in step 2. So you're going to add them all up again. Okay, 2 plus 1 plus 1 plus 1 plus 1 plus 1 plus 1 plus 2, it's 10. And then I divide by the number of data. There's 8. So 10 divided by 8 is 1.25. And that is my mean absolute deviation. So basically, you're finding the mean, you're finding the distance, then you're finding the mean. This is what the mean absolute deviation is. So this is my mean absolute deviation. In the next slide, I will tell you why this matters and what this means, because we all want to know what the heck we're doing, right? So this number, 1.25, means how close your numbers are to the mean value. So if this number is, the closer it is to 0, that means that the mean is a good representation of your data. Okay? So if this number is pretty good, your mean is a good representation of your data. If this number, the mean absolute deviation, is far from 0, say it's like 100, it means that your mean is a bad representation of your data. You should not use your mean to represent your data, because that means your data are too far away from the mean. Does that make sense? Alright, we'll talk more. We're going to have 2 days of this, so if it didn't make sense, don't worry. Just figure out how, just remember the steps. Write down the steps. And then tomorrow we will talk more about why this is important and how we can use it in real life. Alright, let me give you a try it, and then I'll let you go. Okay, find the mean absolute deviation of 3, 6, 6, 7, 8, 11, 15, and 16. And yes, you may use a calculator. I give you permission. Did you have a good time today? Nay. Yes, I did. Nay. Okay, I will see you tomorrow. Oh my gosh, guys. I see you tomorrow. I'm so excited. I missed you all so much. I hope you have a fabulous day. And annyeong.